All right, hey everybody. It is time to go through the 5-2 worksheet about bisectors in triangles, specifically perpendicular bisectors of each side and angle bisectors of each angle. So what is the error a student made in finding the perimeter of triangle DTM? They said DT is equal to 34.5. However, starting right there, DT is not equal to 34.5 because DT is not drawn in by the angle bisectors of the triangle. It's drawn in by creating the perpendicular bisectors of the triangle. And since this is a perpendicular bisector of side DE, then that means that this side length is going to be 33.5 and not 34.5. So let's write that down here. DT equals 33.5, not 34.5. You can tell that these are the perpendicular bisectors because here we've got 29 and 29. So because of that, where it says, let's see, DM equals 34.5, that's not true, okay? DM is going to be equal to 38 because in this triangle where we've created the circumcenter, that means that every single one of the distances from M to the corners here is going to be the same. So if MF is 38, then MD is 38. So DM, let's write this down, DM equals 38. The perimeter then of triangle DTM is going to be equal to 17 plus 33.5 plus 38, which is going to make that 88.5 instead of 86. It's really important to know which of the measures of center carries with it which properties in this case. Number 14, this one's pretty tricky. In a right triangle with side lengths of 3, 4, and 5, so of course this would be side length 3, 4, and 5, what is the radius of the inscribed circle? Okay, so we've got the inscribed circle right here created by the angle bisectors of each of the sides. So it says, hint, let R be the radius, and label the lengths of each segment formed by the perpendiculars to the sides. So if R is the radius of the circle, I could draw that in a few different places. I could put an R right there, going from the center to the bottom. I could put an R right here, going from the center to the side. Now, what that means, since this is a little square right here, created by right angles and side lengths that are all the same, then I know that this is R and this is R as well. That makes these two segments something we can name. If this is R, then this segment is 3 minus R, because it's all of the segment is 3 minus this piece. So we've got 3 minus R. Same thing at the bottom. If this whole thing is 4 and this is R, then this piece of the segment is 4 minus R. Then we know that this is an incenter with an inscribed circle, which means that this triangle and this triangle are congruent. This piece and this piece are going to be the same length. So this segment will be 3 minus R units. And then the same thing for the other segment. It'll be 4 minus R units because it'll be the same as that piece along the bottom. So we end up with this equation that this piece plus this piece equals 5. So we can write 3 minus R plus 4 minus R equals 5. And then we solve the equation. 7 minus 2R equals 5. Subtract 7 from both sides. Negative 2R equals negative 2. Divide by negative 2. And R equals 1. So the radius of the inscribed circle, which we've drawn a lot of places on this diagram, is 1. We'll go ahead and add that as the answer. All right, number 15. The perpendicular bisectors of triangle JKL are PT, QT, and RT. Name 3 isosceles triangles. So if we've got a perpendicular bisector here, here, and here, we have 3 triangles created by this, okay? We know that the distance from the perpendicular bisector to the points is the same. Let me draw in those congruency marks. There, there, and there. And that gives us 3 triangles that we can see right off the bat, right? JTK is got 2 sides that are the same. JTL is isosceles, and LTK is isosceles, because they all have 2 sides that are the same length. So that's triangle JTK, triangle JTL, and triangle KTL. All right, and that happens every time we have the circumcenter made of perpendicular bisectors. Here, using the diagram below, points D, E, and F are the midpoints of the sides of A, B, C. Okay, so D, E, and F are midpoints of the side. So this is the perpendicular bisector of the side. Okay, this is the perpendicular bisector of this side. And this line is the perpendicular bisector of BA. So 16 says, what point is the center of a circle that contains A, B, and C? Well, we would be finding the perpendicular bisector of each side going together, right? That's how we would find the circumcenter that was the same distance from A, B, and C. I can draw that in red. So this point, oops, I guess I can use red pen. This point is the same distance from B, C, and A, because it's made up of the perpendicular bisectors of each side. So point T is the circumcenter, the center of the circle that contains A, B, and C. Which point is the center of a circle that intersects each side of A, B, C at exactly 1 point? That would be talking about the inscribed circle, because the inscribed circle intersects each side at exactly 1 point. And the inscribed circle is created by the angle bisectors. Okay, it's created by the incenter and the angle bisectors. So where do each of these angle bisectors meet? They all meet together at point P. So P would be the center of the inscribed circle. Then it tells us the perpendicular bisector of AB is line M. Okay, they didn't really need to tell us the name of the line, but if we wanted to write it down, that would be this line right here. That's line M, right in the center. And the perpendicular bisector of BC is N. So that would be this line, oh goodness, this line right here is called N. Lines M and N intersect at T, right? Because the perpendicular bisectors intersect at T to create the circumcenter. If TA is 8.2, what is TC? Well, if TA is 8.2 and it's the circumcenter, TC is going to be the exact same length, because the distance from the circumcenter to each point on the triangle is going to be the same length. That's one of its properties. So TC is also going to be 8.2. Down here, find the values. We want to find the value of EG. And we are seeing in this case that we've created angle bisectors. These are where the 2 angle bisectors or the 3 angle bisectors are meeting. So this is the incenter of the triangle. The incenter of the triangle is going to be the same distance from every side, because it could create that inscribed circle that touches every side. So since this point is 9 units away from D, it's also going to be 9 units away from G, or from E rather. So EG is going to be 9 as well. GF is, once again, same thing, because it is from the center to the edge of that inscribed circle. It's going to be 9. Easy stuff. All right. Next, here's a whole bunch of things that we need to write down. If xy is equal to 24, let's break that down because xy has a perpendicular bisector on it. So here's 12 and here's 12. Xz is equal to 22, and again we can break that down into 11 and 11 because we have a perpendicular bisector. And JQ equals 5. Find the values, round to the nearest tenth. All right, so we want to find the radius of the circumscribed circle of XYZ. The radius of the circumscribed circle would be the distance from Q to any point on our triangle, any point on the end of our triangle, because the circumscribed circle is going to come from this point. It's going to touch every corner of the triangle just once. So this would be the radius. That creates a right triangle. Look at the right triangle I've got here, 12, 5, and y. I can use the Pythagorean theorem then to say 5 squared plus 12 squared equals c squared, our hypotenuse. And that is going to be 169 equals c squared. Take the square root of both sides. 13 is the length of c. So 13, being the distance from the center to one of the corners, using the circumcenter, is going to be the radius of the circumscribed circle. All right, the other thing we've got here is QK. So QK, we're going to have to do a little bit of figuring. So here's QK. What I can do is I can say, well, since QY is 13, that's the same as any of these other distances, okay? So if QY is 13, I can also say that QZ is 13 as well, because that radius of the circumscribed circle is going to be the same everywhere around the circle, or everywhere to each point of the triangle as well. So now I have a right triangle where I know that one side is 11 and the hypotenuse is 13. I can use the Pythagorean theorem. 11 squared plus x squared equals 13 squared. So that's 121 plus x squared equals 169. I'm just solving from there. Equals 48. Take the square root of both sides and we get x equals approximately 6.9. So rounded to the nearest tenth, that's 6.9, and that will be our answer for, whatever, okay. That'll be our answer for the length of QK. 25. A ball manufacturer wants to stack 3 balls, each with an 8 centimeter diameter, in a box that is an equilateral triangular prism. The diagram shows the dimensions of the bases. Will the balls fit in the box? And explain how you know. All right, well, let's think about this. If this ball has a diameter of 8, then it's got a radius of 4. So the radius of this ball equals 4, which means if I put this ball in the center of this triangle and the radius to each edge is at least 4 centimeters, then this ball is going to fit, right? If the center of the ball is right here and it goes out 4 centimeters, out 4 centimeters, out 4 centimeters, and doesn't touch any of the edges, or it doesn't go outside of any of the edges, then this ball will fit. So we want to find the length here. We want to find the radius of the inscribed circle. That's what we're going to do. We're going to find the radius of the inscribed circle. And lucky for us, it tells us that this box is an equilateral triangular prism, and it gives us these 30-degree measurements to indicate to us that we have an angle bisector and an angle bisector. So we've created an incenter where our 2 angle bisectors meet each other. So this point is the incenter. We want to find the radius of the inscribed circle, right? We want to find the radius of the circle that goes like, ooh, actually I can draw a circle. Let me do this the right way. So I want to find, there we go. Hey, that actually worked pretty well right away. Perfect. So if I want to find the radius of this circle, I want to find where it touches each of these sides. I'm going to use some, whatchamacallit, I'm going to use the Pythagorean theorem to find the third side of this right triangle. So I can take 7.8 squared plus x squared equals 9 squared, and that's going to give me 60.84 plus x squared equals 81. Subtract 60.84 from both sides, and I end up with x squared equals 20.16. Take the square root, x equals 4.5. So that means that the distance from the center to the edge is 4.5. Which means this ball with a radius of 4 will fit in there because the ball's radius is not going to touch the edge of the package. So the balls will fit. The balls will fit. There you go. Up here, we've got a triangle. In triangle ABC, AB has midpoint M, and L is the perpendicular bisector of AB, and the angle bisector of ACB. Which of the following must be true? Let's draw a triangle and see what happens. Can be any triangle, of course. So we've got A, B, C, because our diagram doesn't have to be accurate. And AB has the midpoint of M. So this is M. We learned that it was the midpoint, so we can put those marks there. And L is the perpendicular bisector of AB and the angle bisector of ACB. So this line is going to go like this. I'm going to go through point C. It's going to be the perpendicular bisector and the angle bisector of ACB. Which of the following must be true? A says the radius of the inscribed circle of ABC is AM. That doesn't make any sense. This is never the radius of any inscribed anything. So that's not true. It says AC equals CB. That is true, because if we have this angle bisector creating a perpendicular bisector, then we are creating an isosceles triangle where AC is going to equal CB, because we know by angle side congruence that these two triangles have to be congruent. So this is true. Then it says both the circumcenter and the incenter of ABC are on line L. Of course, this is line L. So if line L is the perpendicular bisector of this side, and it is the angle bisector of this angle, the circumcenter is on it because it's a perpendicular bisector, and the incenter is on it because it's an angle bisector. So both of those points will be on this line somewhere. They might not be the same point, but they'll be on that line. And then finally it says the circumcenter of ABC is inside the triangle. Well, we don't know what kind of a triangle this is. We don't know how big the angles are. We don't know whether this is an acute triangle, where the circumcenter is always on the inside, or an obtuse triangle, where the circumcenter is always on the outside. It could be either one. So we don't know that for sure, which means we can't put D. Number 28, again, we've got a triangle, ABC. So it says circle O intersects AB only at F, BC only at G, and AC only at H. So let's draw a triangle. No? Let me try this again until I get a triangle it likes. There we go. So let's see. And then there's a circle inside of it that intersects at 3 points. So this is ABC. and we'll draw a circle inside of it, and we'll adjust that until we get a circle that's big enough that it intersects each side only once. And close enough. Okay, so we can sort of assume that this is touching once at each side. So it intersects AB only at F, intersects BC only at G, and intersects AC only at H. Which equation is true? Well, if this circle intersects with the triangle, the circle O, I'll put the center there, circle O, intersects the triangle at each side, then this must be the inscribed circle, okay? And let's think about what we know since it's an inscribed circle. First of all, it says AH equals AC. Not necessarily true. The inscribed circle, we can see it better here, doesn't touch at the midpoint of the side. So that's not true. The B, the measure of angle OFB equals 90. Well, if we're measuring from the center to the edge where this touches, that measurement is going to be 90 degrees. Not necessarily a perpendicular bisector, but it is a perpendicular measurement to measure from the center of the circle to where it touches the edge. So that is true. Which of course means the rest of these aren't true because it's not a select all that apply. All right, if you have any questions about this worksheet, please don't hesitate to ask. And thanks so much for listening. Have a wonderful day.